Welcome to qnawire.
First, we need to understand that the settling velocity of a particle in a fluid is given by Stokes' law. And this Stokes' law states that the settling velocity is directly proportional to the square of the particle diameter. It is also proportional to the difference in density between the particle and the fluid, and it is inversely proportional to the viscosity of the fluid. Then the settling velocity can be calculated using the formula g multiplied by d raised to the power 2 multiplied by rho p minus rho f, and all of this divided by 18 multiplied by mu, where g is the acceleration due to the gravity, which is 9.8 meter per second square, d is the diameter of the particle, rho p is the density of the particle, and rho f is the density of the fluid, and mu is the viscosity of the fluid. Here, given the specific gravity of quartz and galena, we can calculate the densities as follows. We can calculate the density of quartz, which is equal to the specific gravity of quartz multiplied by the density of water. Now plunging in the values, the specific gravity of quartz is 2.65 multiplied by the density of water, which is 1000. Upon solving, we'll have 2650 kilogram per meter cube. Similarly, we can calculate the density of galena by multiplying the specific gravity of galena multiplied by the density of water. So, the specific gravity of galena is 7.5. Multiply this by 1000. We'll have 7500 kilogram per meter cube. So, this is the density of galena. Now, we can calculate the settling velocities of the smallest and the greatest particles of the mixture for both quartz and galena. For quartz, the settling velocity of the largest particle would be, according to d is equal to 0.00001 meter. So, the settling velocity would be equal to approximately 0.0000003 meter per second. Accordingly, when we put in the values for the settling velocity of the smallest particle, according to d is equal to 0.0000002 meter, so we'll have the velocity as 0.0000006 meter per second. Similarly, for galena, the settling velocity of largest particle upon calculation will be equal to 0.0000009 meter per second, and the settling velocity of the smallest particle would be equal to 0.00000 0.00018 meter per second. From these calculations, we can see that the settling velocities of the smallest and the largest particles of quartz are lower than those of galena. This means that in a hydraulic classifier, the quartz particle will be carried away with the water flow, while the quartz particles will be carried away while the galena particles will settle. Then, therefore, the size ranges of the quartz and galena in pure products will be same as the size ranges of the particle in the original mixture. That is from 0.0002 centimeter to 0.001 centimeter. So, this is the final answer to the question.